right, so we're going to continue working on the characteristics of functions flip chart that we started today in class. So we are going to just double check on domain and range. The domain is talking about the x values, so you're going to start with the smallest x to the largest x, and then the comma represents everything in between because there would be no way for us to record all of those numbers. For the range, we're talking about the y values, so we're going to write the smallest y to the largest y with a comma in between because there would be no way for us to write all of the different y values of a function. So that's how domain and range are going to look most of the time. All right, next up, we are going to do the intercepts. So on your intercepts page, I'm going to, again, split it in half. And that's because we have two intercepts. We have the x-intercept, and we have a y-intercept. And they are similar, but obviously slightly different with respect to which intercept we're looking at. So for the x-intercept, it is a point. So that means it's an ordered pair. It is a point where the function crosses the x-axis. So if we're looking at a graph, we're going to follow the function, and we're going to find the point where the function crosses the x-axis, and that point is the x-intercept. So when we go on a graph, the x-axis is where y is always going to be 0. So the point for the x-intercept is always going to be something 0. All right, similar to that is the y-intercept, except this time it is going to cross the y-axis. So we are talking about the point where the function crosses the y-axis. And similar to the ordered pair here, the y-axis is where x is 0. So your ordered pair will always be 0 something for the y-intercept. All right, next one. We're going to go on to maximum or minimum points. So we flip this page. So now we're on maximum and minimum points. And again, I'm going to split my page in half because we have two different ones that we're going to talk about. I think this one makes total sense because the maximum point is the highest point on the function. So maximum point, the highest point of the function. And again, it's a point, which means an ordered pair. So the highest point of the function. So just to give a sketch to this one, if we had just a little XY graph here, if we had something like that as our function, then this right here would be the maximum point because that would be the highest point on the function. So we would write it as an ordered pair. All right, so again, very similar but opposite. The minimum point, so the minimum point is going to be the lowest point of the function. And again, it's a point. So it is the lowest point of the function. So to give a sketch for this one, let's say we had something like W. All right, in this case, we have two minimum points. So we have a minimum point over here. Maybe this is at 1, -2. And then here's another minimum point over here. Maybe this one is like -2, -2. So it's possible to have 1 or 2, or it's even possible to have none. So this is an example of that situation. So let's say, because last year you guys did linear functions, so let's say we had an equation of a line. So if we had an equation of a line, we know that the graph is just going to continue on in both directions. So if we were asked for a maximum point, is there a highest point on the line? No. And for the minimum point, is there a lowest point on the line? And the answer would be no. So it's possible to have none, to not have a maximum or a minimum point on the graph. All right, I think that is going to cover it for now. We will get together tomorrow in class and complete the rest.